So looking at polynomial functions and determining what we have as far as zeros, solutions, x-intercepts. These are all somewhat interchangeable. If you're looking at the equation, usually it's the zero or the solution. If you're looking at the graph, usually it's called zeros or x-intercepts, but essentially they all kind of mean the same thing. So a zero is where I'm setting my equation equal to 0. So zeros are where you set your equation f of x equals 0. Okay. So here we have three equations. And so A as my equation is essentially the same as A as my graph. All right. So this equation has the graph. And the zeros, so where we set my equation equal to 0 would be where I'm crossing the x-axis. So if I look at this first graph, I'm crossing the x-axis in 3 places. So there's 3 places where I get 0 as an answer. Okay, so there are 3 zeros, and there are also 3 x-intercepts, 3 solutions. All right. Degree is the largest exponent, which would be the exponent on this x to the third. So my degree is actually 3. All right, let's look at the next one. So once again, my zeros are where my equation is equal to 0. This is graph B for equation B. What are my actual zeros? By looking at the graph, they're here and here. So the places I've colored in red, where I'm crossing the x-axis, are my zeros, my solutions. There are 2 of those, 2 x-intercepts. And my degree, value with the largest variable, the largest exponent. Okay, so the degree on this one happens to be 2. And then let's look at the last graph. So again, zeros where my equation is equal to 0. And then looking at the graph, I can see that there are 4 places, 4 zeros, where I cross the x-axis or have my x-intercepts. What is my degree on this one? X to the 4th. 4 is the largest exponent, so the degree is 4. Okay? All right. So what I should notice here is that the degree and the zeros are all exactly the same. All right? So the thing is that your degree in your polynomial is actually the max number of zeros. I'm going to add the word max because I can't have more than that. I could possibly have less, but there's no way I can have more. Okay? If I look at this parabola as an example, let's look at a possible parabola. So I could have this parabola. Notice there are no zeros at all on that parabola because it never crosses the x-axis. I could also have this parabola here, which actually just sits on the x-axis, and that has 1, 0. And then if I think about a parabola, the only maximum number it can crossings it can have is 2. So it's kind of how many lines you can have in your equation, and that is pretty much the maximum number of zeros you can get. Okay, so I can have 0, 1, or 2, but there is no way I can have 4 for equation B. So for equation B, I can have 2, I can have 1, 0, I can have no zeros, but there is no way I can get 4 zeros out of a graph that just is a U shape. All right. There's an error right there. That shouldn't say 2, that should say 0. Okay, so that's equation to graph to zeros by looking The other thing you can do, and I'm going to use equation B as my example, is I can set it equal to 0 and solve. So I'm using this strategy here. X squared minus 9 equals 0. Well, what do I have to do? I have to factor x plus 3, x minus 3 equals 0. Okay, what do I do from there to finish solving? X plus 3 equals 0, which means x is negative 3. So that is one solution. My other solution is x minus 3 equals 0 and x equals 3. So that is my second solution. If I look at these solutions, well, hey, here's negative 3, here's positive 3. So we should notice that the zeros, the solutions, the x-intercepts are all the same points. If I have the solutions, I also have the x-intercepts because I have the point. Okay, so if I have the solutions, I have the x-intercepts because I have the point negative 3, 0. And I also have the point, the other x-intercept point of 3, 0. All right, so solutions are zeros, are x-intercepts, and even more. If I have a solution, I also have the factor that connects to that. So they're all interconnected, and essentially they all tell you how the graph works on the x-axis and kind of some key points about the graph. Okay? All right, so graphing, looking at x-intercepts, finding solutions, zeros, and basically moving forward into given information, what can we determine about our equation? That is the goal of zeros and x-intercepts today. All right, so if we are looking at solving by factoring, okay, what is our first goal when we're saying solving? What we're saying for our equation, f of x. So to solve it, essentially what it's always telling you is make it equal to 0. So I'm saying I want my equation equal to 0. So what I want is x squared minus 5x minus 14 equals 0. Then I factor it. So that's going to be x minus 7, x plus 2 equals 0. Continuing onward, each factor equals 0. So x minus 7 can be 0, or x plus 2 can be 0. So my solutions are x equals 7 and x equals negative 2. So there's my solutions. There's my zeros. If I wanted my x-intercepts, they would be the point 7, 0 and the point negative 2, 0. So remember, these are always points on the x-axis. So there's the solution to question A. Okay, let's look at question B. So one more example. G of x equals 0. That means 4x squared minus 9 equals 0. That's a difference of perfect squares because 4x squared is squaring 2x and 9 is squaring 3. So I should know that my factor set is going to be 2x plus 3, 2x minus 3 equals 0. Setting each factor equal to 0, 2x plus 3 is one choice. 2x minus 3 equals 0 is the second choice. What do I do? Subtract the 3. So subtract the 3. And I'm going to get 2x equals negative 3. Divide by the 2. X equals negative 3 halves for my first solution. On the second option, I'm adding 3. So 2x equals 3. So my second solution is x equals 3 halves. This is my solutions. Now, if I want to write x-intercepts, I might maybe Might want to choose to put it in decimal set, because then I can write negative 1.5 and 0 for my first point, and 1.5 and 0 for my second point. So I may choose to do that just for ease of graphing if that happens to be the 0 set. Okay, but the process is the same. Set it equal to 0, factor, and solve. If you have a larger degree or you have something that doesn't factor, so if you have something that doesn't factor, I'm not going to do this problem, but if you have something that's prime, then your zeros, your solutions, x equals is the quadratic formula. If it's x to third or x to the fourth or whatever, there's some other strategies. Mostly for the purposes of this lesson, for factoring, we're dealing with stuff that's x squared. Or if you have larger than 2, don't forget your first step is check for a GCF. So if I have something like x cubed minus 4x, then the first step is x equals x squared minus 4. So pulling out that GCF of x. So you might need to do that as well. So if I have my equation, I can solve it. Once I solve it, those are the solutions, the zeros, the x-intercepts. Okay, let's say we have the zeros already. So I already have an equation, or I already have zeros. So I have solutions, okay? These are the steps I must follow, 1, 2, and 3, in order to get my solutions back into an equation. So I'm dealing also with polynomial sets. So I have some rules about how they work. First of all, I know, since these are the given sets, that x equals 3, x equals negative 5, and x equals 4 are my solution values. What does that mean? That means that it came from x minus 3 equals 0. So my solutions are zeros, so x minus 3 equals 0, x plus 5 equals 0, x minus 4 equals 0. Where did those come from? They came from factors. So essentially, these are factored sets. So I can write my equation, a possible equation, as x minus 3, x plus 5, x minus 4. This is essentially the simplest equation. I can put various numbers out here. So I could say, well, multiplying it by 2, or negative 2, or negative 10. But essentially at this point in time, all I'm worrying about is finding the actual solution. So I'm going to be using a standard value of 1, which you don't usually show, okay? And that's what I'm going to be using for my purposes of doing a basic explanation of this. So this would be factored form. Okay, if I want it in standard form, what that means is expand. So multiply it out, okay? So step 1, multiply 2 of the values. Doesn't really matter which 2. In this case, I'm going to just multiply these 2. And what I'm going to get when I multiply that, distributing, so x times x is x squared, plus 5x minus 3x plus 2x minus 15. So that's my first term, first 2 terms multiplied, and then I still have something I need to do, x minus 4. Okay, I can do a full distribution set here, or I can use box method. I prefer box, so I'm going to do a box. So x minus 4 is one of my factors, x squared, 2x minus 15. Essentially, I need a space for each quantity. Then you just multiply. So x times x squared, x times 2x, x times negative 15. X to the third, 2x squared, negative 15x. Next row, negative 4 times x squared, negative 4 times 2x, negative 4 times negative 15. Negative 4x squared, negative 8x, and 60. Now I look for my like terms. Generally, in this method, the like terms end up in the diagonal, x squared and x squared, x and x. So I'm just going to write my final answer in expanded form. F of x equals x to the third minus 2x squared minus 23x plus 60. And that is how you expand your set. If you have the zeros, working backwards to the factors, multiplying them out. Generally speaking, when you're doing this, you're trying for a polynomial set, so no weird stuff like square root of x or whatever. Okay, so the last thing I want to talk about today is the remainder theorem. Essentially, the remainder theorem just says if it's a solution of the polynomial, then when you put in the value, it will give you 0. So your goal is f at whatever you're checking should be 0. Okay? So what am I looking at for my equation? My equation is right here. F of x equals 3x cubed minus 11x squared plus 4x plus 6. And essentially, I'm trying to decide if this is a factor. So if I look at A, and I'm saying, is that a factor? So if that is a factor, what that means is x minus 2 has to be 0. That means x is 2. So if I put 2 into my equation, so I'm replacing all my x's with 2's, and then I evaluate it. I'm trying to see if it's 0 or not. That's my goal. Okay, so I'm going to have 2 times 2 times 2 is 8, minus 11, 2 times 2 is 4, plus 8, plus 6. Okay, so let's see, I'm going to have 24 minus 44 plus 14. That's negative 20 plus 14. I could stop here because it's clear to me that this is not 0. Or I can finish it out and say, you know what, okay, it's really negative 6. But basically, what does that tell me? What am I trying to find out? Whether or not x plus 2 is a factor. So what am I going to say? X minus 2 not a factor of f of x. Why? Because if it was a factor, my answer would have to actually be 0, and it's not. So it gives me a number, but it doesn't give me an x-intercept. Okay? All right, I'm going to do C next because I'm going to have to move B off to the side. So let's look at C. 3 value cubed minus 11 value squared plus 4 times my value plus 6. Okay? This, my solution, x minus 3 equals 0, x equals 3. So if I put 3 into my equation, do I get 0? So let's see. That's 3. 3 times 3 times 3 is 27. Minus 11. 3 times 3 is 9. Plus 12. Plus 6. What do I have now? 3 times 27 is 81. Minus 99. plus 18. All right, so it's equals. 81 minus 99 is negative 18 plus 18. Hey, look, it is 0. Yay. So what did I just find out? X minus 3 is a factor of f of x. Okay? So that is what I found out. Okay? All right, I think it's valuable to do b just because that's the only negative one. So x minus 3 is a factor of f of x. Let's go for b, x plus 3. So x equals negative 3 is what I'm trying to evaluate. So same idea, same equation. So put in my numbers and then feed in the value I'm checking. So negative 3 goes in for x in the equation. And then what do? I start evaluating it. So 3, negative 3 times negative 3 times negative 3, negative 27. Be careful with this. You've always got to do exponents first. Okay? This one's a little harder because of the negative running around. Negative 3 times negative 3 is 9. Be careful with your signs. 4 times negative 3, negative 12, plus 6. What do I get next? Negative 81 minus 99 minus 6. And what I see is I have negative, negative, and negative. So that is going to just turn into some negative large number. Definitely not 0. Not 0. So what did I just find out? It didn't ask me to evaluate it, so I can stop here. What I'm going to say is x plus 3, not a factor. Okay, so I had one where I actually did get 0, so that is a factor. And then 2, where I did not get 0 as my answer, so they are not factors. So that is the end of this lesson.